All right, you guys, these are the last set of notes for this 9 weeks. Yay. Okay, so the discriminant, that's your purple paper. All right, the discriminant is an expression that comes from the quadratic formula. So you see up here, I've got the quadratic formula. The expression that's under your radical, b squared minus 4ac, that is called the discriminant. That is a very useful number. If I know what that number is going to be under the radical, it can tell me the type of solutions that I'll have in my quadratic before I even solve it. That means I'll know if it has real, imaginary, or if it's going to be a fraction or have a radical type answer, and radical is using the square root. The discriminant will tell me all of that. Okay? So let's go down here. So go ahead and write that. All right, so when I go down here to the bottom, it's telling me or asking me what information does it provide. So if our discriminant, D, is greater than 0 and it's a perfect square, I know that I'm going to have 2 roots, and I know that they'll be real numbers, and I know they'll be rational. Rational means it's an integer or a number that can be expressed in a fraction, like 3/2, 1/2, things like that. Okay, and it makes sense because if this number under this radical is a perfect square, like 16, all of this would turn into a 4, similar to the one that we just did on the other nodes, which means I'll get an integer or a fraction as an answer. Okay, so the next one, if the discriminant is greater than 0, but it's not a perfect square, I'll still have 2 roots. They will be real numbers, but they're going to be irrational. Irrational means that it wasn't a perfect square, so I'm going to have some weird answer like 2 root 3 or something like this that we've been working with. Some type of radical that didn't simplify all the way. Okay, that's your irrational number. If the discriminant is equal to 0, you're going to have one real rational answer. One real rational answer. And if the discriminant is less than 0, which means this number under the negative is a negative number, because less than 0 means it's a negative number. And my laptop is starting to mess up. But if it is a negative number, and I wrote it on the wrong one, I know, I get it. So can I move this down? This belongs down here. I am really messing this up. Move you down here. Then I am going to get 2 imaginary or complex solutions. So I'll get 2 imaginary It's messing up, y'all. I'm sorry, but you have to bear with me. It doesn't like 2 notes in a row. Two imaginary complex solutions. All right, let's go down here. So 1 through 4, we're going to find the value of the discriminant and then determine the number and type of roots we have. So I'll do the first one with you. My A is 2, B is 12, and C is negative 13. So the discriminant is B squared minus 4AC. That's 12 squared minus 4 times A, which is 2, times negative 13. So go ahead in your calculator and find this value. 12 squared is 144. plus this value here is 104. And this gives me 248. That number is greater than 0. It is not a perfect square, so I'm going to get 2 real roots. And you don't have to really tell me rational or irrational. That's really for your knowledge. So just tell me 2 real, 1 real, or 2 imaginary. Okay, that's a discriminant. So you do 2, 3, and 4. As you do them, go ahead and pause the video. I'll write the solutions up here. Make sure you pause the video. Okay? So this one, you'll get a discriminant is equal to 0. And this should give you 1 real root. This one should give you a discriminant that's equal to 1,444. That means we'll get 2 real. Let's see if I move back. Nope. And number 4, the discriminant is equal to negative 288. Oh, come on. And that means that I'm going to get 2 imaginary roots. Remember that imaginary numbers means that my quadratic won't touch the x-axis. It's up here somewhere, okay? Or down here. You never know. Alrighty. So once you find the discriminant, then we have insight on what our solutions will look like. Okay, let's go down here on our choosing the best method to solve. Okay, so this is how we can tell what is a good method to use based on the function that we have. Graphing. We can use this sometimes. When is it the best time to graph? When our roots are integers. Okay? And I'm going to put on here not usually practical. It's not usually practical. Students will rather solve them. I've never heard a student say, wait, let me graph it. So no, not really practical. We try to find another method to solve it. All right, factoring. Can we factor all quadratic functions? No, they're not all factorable. So we can only do this sometimes. When is it the best time to use the factoring method? When the roots are rational. And I'm going to go ahead and say when the roots are integers, that's when it's the easiest to factor. So integers or rational. Okay? All right, next one, square roots. Can I take the square root of all quadratics all the time? No. Only sometimes. When is it the best time to use the square root? when there is no B term. That's that X term. Okay? Completing the square. Can I complete the square in every quadratic? Yes. You can do it for every single one. We can do that always. But when is it the best method to use? When there's no x squared coefficient, there's no x squared coefficient, and B is an even number. Like 8x, 6x, 4x, when B is even. Okay? Last one, quadratic formula. Can I use that on all quadratics all the time? Yep. So always. When is it the best time to use it? When is it the most efficient? So we're going to say anytime all other methods are inefficient. And that is an E. My laptop is messing up. Okay? So those are all the methods, and those are the most efficient times to use those methods. All right? Now turn your paper over. We'll go down. Okay. On the back side, we've got 4 functions. Directions say find the discriminant of each equation and give the number and type of roots. So we're going to find the discriminant, and that's your b squared minus 4ac. So I'm going to write this on the top. B squared minus 4 times a times c. So go ahead and find the discriminant for each one of these first and identify the type of roots. Okay, first one, negative 9 squared minus 4 times 1 times 21. And this will be 81 minus 84. And that makes it negative 3. So for the first one, if you look on the other side of your paper, if I get a negative number for the discriminant, what type of solutions will we have? Negative number means it's less than 0, so we're going to have 2 imaginary or complex. Okay? All right, so find the discriminant for the next 3 and then identify the type of roots. Pause the video now. Okay, hopefully you did it on your own and you're not waiting to copy. But for B, the discriminant was 1152. Greater than 0, not a perfect square. So this one is going to give us 2 real roots. And I know that they're going to be irrational only because that's not a perfect square, 1152. And you can tell by put square root of 1152, see if it gives you an integer. If not, it's not a perfect square. Okay, next one for C, the discriminant was 400. 400 is a perfect square, 20 times 20. So that means I'm going to get 2 real roots, and they're going to be rational. You don't need the rational, that's just a little extra. All right, and the last one, D, the discriminant was 96. 96 is not a perfect square, so I know I'm going to get 2 real roots, and I know they're going to be irrational. Okay, so those are our 4 solutions. So now our 4 discriminants. So now what we need to do is we can only use, so number 2 says solve each equation using the methods below. You can only use each one once. So now what I want you to do is I want you to pause the video, but determine which equation is it best to use which method. So you're going to put a letter in the box for the equation that goes with that method. Turn your paper over, look at all of those methods, when to use them, when it's the most efficient, and see what you get. Go ahead and pause the video. Okay, you should be done by now. So here's what we got. If I look at the solutions, the first one, taking square roots, this one should be B. And I know that right away because when you look at B, it doesn't have that X term. So I know taking square roots of both sides will be most efficient. The next one is factoring. And it's most efficient to factor. If I look on the other side, it says when the roots are going to be rational numbers, integers. So here I know I got 2 real roots here, and that's the only one that had rational. So I know that factoring is going to be C. Then I do complete the square. When is it most efficient to use complete the square? That would be D. Okay? And for D, completing the square is good because there's no coefficient for x squared, and my B term is an even number. So this one would be D. And A will go right here for quadratic formula, because I know if I have 2 imaginary numbers, I'm going to have a square root in my answer. And if I can't take the square root, I'm going to have to use a quadratic formula. So that one goes there. So now what I want you to do is pause the video and go ahead and solve each of these functions using those methods. Okay? Okay, hopefully you unpaused it. You've already solved it on your own. You use these methods. For the factoring, the function was 3x squared minus 22x plus 7 equals 0. The 2 factors are x minus 7 and 3x minus 1. And you either need to ask Mr. Stoddard or someone to help you how I got that, because you got to know how to factor. We said each factor equal to 0, so I'm going to make this little chart to help remind me that this one gets set equal to 0. And this one gets set equal to 0. So here x is 7. And this one I need to add 1. 3x equals 1. Divide by 3. I get x equals 1/3. So there's our solution, 1/3 and 7. Now I'm not going to solve all these. On the square root one, that one was your B. So negative 2x squared plus 144 equals 0. I would need to move the 144 over there. I get negative 2x squared is equal to negative 144. Divide by negative 2. I get x squared is equal to 72 square root, both sides. x is equal to plus or minus the square root of 72. You need to break 72 down. This is 36 times 2. Okay, and I know that that's ugly, so let me fix it. So this breaks into root 36, and that's even uglier, times the square root of 2, 36 times 2. So then x is going to equal to plus or minus square root of 36 is 6 root 2. That's your answer. So x equals plus or minus 6 root 2. That's my curly brace, sorry. All right, complete the square. I need you to complete the square like you did on the front. 4x squared plus 6x minus 15 equals 0. And you should get the roots of negative 3. X is equal to negative 3 plus or minus 2 root 6. That's your solutions for that one. And the last one, quadratic formula was for a, x squared minus 9x plus 21 equals 0. And if you use the quadratic formula, you will get x is equal to 9 plus or minus I root 3, all divided by 2. Okay? Alrighty. So now that you've got that, the sub will have your assignment where you will practice all of these solving methods and knowing which one is the most efficient so you don't try to factor something that has imaginary roots. All right? I will see y'all later.